Today, we are going to write a Python script or a couple of Python scripts to find some information of interest on a website URL and write it to the screen, do some filtering of that information, and then write it to a file. So for this work, what we're going to be looking at as a motivating factor is the data of something from radio called maximum usable frequency. There is this website, prop.kc2g.com, which is made possible by funding from the following: the Worldwide Radio Operators Foundation, a relatively recent addition to the community. In 2009 is when they were founded. They're in collaboration with NOAA, National Oceanic and Atmospheric Administration, from the US Department of Commerce, and GIRO, the Global Ionospheric Radio Observatory, which looks into these ionoson stations all around the world. GIRO, I believe, is an initiative from UMass, University of Massachusetts, Lowell. So what is MUF all about? Well, if we go in here, we have a very nice plot highlighting these circles in which what we've got is the MUF at different stations around the world. Now, these stations are measuring the maximum usable frequency using these devices called ionosons. And those are fascinating devices that can be understood in a simple way as upward facing radars. Then what they return, when the signal returns, it tells you what frequency you're able to discern, to see that came back. If the signal, say up in northern Norway, they sent a series of frequency, but only the 6 megahertz frequency came back, it gets a value of 6. On the other hand, if you're in Southern California, remember this is where the sun is hitting right now this morning for them, then it's 32 megahertz because their ionosphere is much more excited than the ionosphere over here on the dark side of the planet. So that's all interesting. Another way to look at this MUF is, of course, dealing with the refraction by the ionized layer of the atmosphere. And again, remember, because of the curvature of the Earth, normally at some frequencies, we're only able to talk line of sight. But because of the ionized layer or the ionosphere, our signals from the transmitting antenna experience this refraction. And sometimes the refraction is acute enough so that the entire signal gets bounced back. And you can see that it actually can work for our advantage as radio amateurs because we can have multiple skips. And from a transmitting antenna on one part of the planet to a receiving antenna way on the other side of the horizon, we can actually establish communications. Now, the interesting parameter here, or concept here, is the one of frequency of transmission signal. The transmitting antenna can be outputting, say, F1, F2, and F3 frequencies. So just for argument's sake, let's say that the F3 frequency is 7 megahertz, or in the 40-meter band. So the transmitting antenna will go ahead and send its signal, and it will get refracted all the way down to a station on Earth. However, say the transmitting antenna tries to go ahead and transmit at a higher frequency. Maybe the operator switches to the 20-meter band. In that case, a transmitting signal, transmitted wave, goes up to that initial layer where the 7 megahertz frequency was being bounced back or refracted back. And we definitely see that some refraction takes place in that layer, but not enough to bend the entire frequency, the entire signal. And it actually makes it through to a second layer, in this particular case, the F layer in this example. And then there it gets refracted and gets refracted down, so it comes down to our station here, which actually might be a better band to use because we have longer propagation distances. Now, along this analogy, let's say we have a third frequency, F1, which is maybe the highest frequency, say, for example, 21 megahertz, just to pick one as an example. 21 megahertz gets even less strongly refracted by this layer. It gets refracted a little bit by this layer, but not enough to manage this refraction all the way down to Earth, and it continues going. So essentially a maximum usable frequency would be somewhere between 14 megahertz and 21 megahertz in this simplistic example. So based on that explanation, quick explanation, we can see that the concept of a maximum usable frequency is a very much of importance to radio amateurs. And this illustration gives an idea of scale. The ionosphere is way up there, and these are the clouds and storm systems on the planet. But the ionosphere is way up higher. So if our frequency of transmission is at the maximum usable frequency, we might actually experience some channeling and then refraction down to the planet. If it's higher than the maximum usable frequency, it gets propagated into space. It gets refracted, to be sure, but not enough to bounce back. So given that, we're very thankful again to this collaboration of Giro, NOAA, and the WWROF, and the Open Source Foundation that makes a lot of these tools are able to be used for this compilation of the data. Talking about which, that's where we jump in. This is the data of the stations that we care about. There's about 100 stations here all around the world. And what we want to do is we want to go ahead and cut all this data and work on it somehow. So let's go ahead and select it and then say Control C and then bring up a terminal window or something that will allow us to write our program and work on this data. So PWD, we are the root. We go ahead and say CD, PRO, and tab. That's a shortcut Unix way to actually go to the next directory. And then we do CD Python, again, to Python directory, we go there. And then what we're going to do here is, we're just going to be in this working directory. PWD is the program's Python directory. That's where we're going to work. So what we want to do then is say VI, and we're going to call it data.txt, return, and we have a new file. We click I to insert and Control V to insert our contents from the clipboard. Now we say :WQ to write it, and there's our file. If we say ls minus la dat tab, we see that there's a file. It's read, write only for root, read for other users, and it's it's not a big file. It's 8,700 bytes, I guess. So that would be that's what we have. That's where this data has been copied. Now, notice that we did it manually. Now what we want to do is bring up Python. So for that, what we're going to use is VS Code. It's a very good program, interactive development environment, or IDE. And what we're going to do is we're going to start a new file, text file, and it's going to be, let's go ahead and see if we can save it. Save as, and we're going to go ahead and go into, this is the Python subdirectory there. So let's create a new folder called my MUF project. We create it. And now here what we're going to say is my muf.py. .py is always the extension you want to use for Python programs. So we say save, and that's what it is right now. So we're starting to code right now. Now what we do always in the first line of any Python script is do the shebang line, and we tell it user bin environment Python 3. The next thing we want to do is import the pandas library. And it is a very useful library, but instead of writing pandas all the time, we're going to go ahead and make it import pandas as PD. So we don't have to be doing pandas.method. It'll be pd.method. Okay, so first thing we want to do is reading flat file using pandas. And for that, what we do is we use the read CSV method. So for that, what we say is, say, for example, we have a data frame called MUF data equals to PD, remember that's pandas, and the method is going to be read CSV and we're going to open a parentheses, say data.txt, close, and then we're going to note that if we go over here to the file that we wrote here, in data.txt, it actually has these delimiters separating the different columns. So we're going to go ahead and say account for separators equals to \t. Okay, so now that should have that data frame right there with the contents of that data file. Now, what we want to do over here is, remember the whole explanation about MUF, we want to set a minimum threshold frequency so that we are only looking at MUFs above a particular frequency. In other words, we want to see if we can get to the 20-meter band, and then what else, what other band higher than that can we get to? So we define another variable called MUF equals to MUF data, and we go ahead and now we're accessing the actual data frame data, MUF data, and then specifically the column that we're going to be looking at is MUFD, okay, and that is going to be outside of that square bracket, and it's going to be greater than 14,150. Why 14,150? Just because I want to see anything higher than the 20-meter band, okay? And now, so that's all we have to do right there. We read the file that we just created manually, and we separate MUFD column greater than 14,150. So let's see what it looks like right now. Print MUF, and we should be good. Now, for that, we use this nice functionality here in the VS Code IDE, which gives us essentially a terminal window in our IDE right here. So all of the usual suspect commands from Unix exist here. So we can say cd programs, pro tab, remember that's our shortcut. We can say Python, py Python, and then we can say my MUF project. So using tabs really helps out here. So once we're there, we do pwd, present working directory is that. And if we say ls, we have my MUF.py. So all we'd have to do is run this program, which is true. But remember, what he's going to be looking for is this data file. And if he does not find the data file, he's going to croak. So that's not a good thing. We don't have the data file there. So let's make darn sure where we put the data file. pwd. Okay, we put it in Python. So let's say move data.txt to my MUF project. So we do that. And now if we do the ls one more time, and for that I can do the up arrow just like in Unix, we see data.txt. Before we get carried away about actually running my MUF.py, let's go ahead and do an ls-la just for grins. And we notice something interesting here. We were about to run my MUF.py, but notice the attributes of this file. They're only read, write, for root, and read and read. So if we want to execute that Python script, he's going to say that's not going to work. So we need to go ahead and do a change mod. And remember this nomenclature of 700 or 666. It can be explained somewhere else, but suffice it to say that the 7 corresponds to read, which gets assigned 4, a value of 4, write, which gets assigned a value of 2, and x, which gets assigned a value of 1. So 4 plus 2 plus 1 is 7. That's where you get 7. And here we have 4 and 4 for these two reads, but we're going to replace those with 0, 0. In other words, nothing, nothing. So only root is going to be able to run this. Since I'm the only one running this in this computer, that's fine. So we'll say my tab, again, using our shortcut there from Linux or Unix, and then we go ahead and say return. Now, if we do up, and do ls-la, we notice now that our my MUF has changed from essentially a 644 to a 700 permission. So now we're able to run it. So now if we say run it here, the file mif.py, we don't get anything out. Okay, so let's go ahead and see why that is the case. That is the name of the file. But what we haven't done is we haven't saved the file. How do we know that? Well, because you see this button right here, that circle, and also it's highlighted here as something to do. So we need to go ahead and say, save this file. So for saving, we can go ahead and say file save, or we can do Command S, and then it switches to X. Once it's there, then we can go ahead and run it. So once we run it, we see that we have gotten quite a few of these contents. So that should be what, I don't know, quite a few of those lines. It's not 100 lines now because we've already gone ahead and separated only the data lines that corresponds to MUFDs, which are this column right here, that are greater than 14150. So that's what we're saying. You don't see anything below 14150. That's expected. So we've already done what we needed to do. We're good to go. So next, what we can do is we can go ahead and comment this out, and we can say, okay, now let's say comment. I want to only print out or output USA stations. And why USA stations? A geographical convenience. In other words, I want the MUF around where I live, not around Russia or Brazil or anything else, but around where I live. So here what I can do is say print. Well, before I do this, I need to go ahead and define my variable. Call it only USA stations and set that equal to. Again, in the pandas library, we have this other method called MUF.loc or lookup or localize. It's essentially lookup, LOC. So we're going to go ahead and say that is MUF, and in that particular data frame, we're going to be concentrating on station column, and we're going to say dot string, and we're going to in that string what that string contains, parentheses, USA, and we get an accent. So we have to do that, USA, that. So that should have done it. Close that parentheses, close this, and now the only thing we have to do is print the output. Print the USA stations. Print only USA stations there, and we're going to go ahead and do this. It's going to be station. So we want a little bit more than just those stations. We want to say specifically, give me the station, give me the time, and give me the specific MUFD, right? So there, the other thing we want to do here, we're combining quite a few things in this print statement, which is great. We're going to say sort values there, this method right here. And we're going to say, look at the column that's MUFD and sort of descending. So we see which is the station that's got the best propagation right now in the USA. So we say ascending. I know this is counterintuitive, but we're going to set this to false. So ascending equals to false means, means that's descending. So now we go ahead and say, remember, we're seeing the circle up here, so we have to say Command S to save, and we'll go ahead and clear and run the script. Okay, cool. So those are the USA stations, and that's it. That's what we wanted to do. And notice that they are descending in MUFD. So that's exactly what we told the program to do, and that's exactly what he's doing. Let's go ahead and, as a final part of this part of the exercise, finally write out to file format our output. In other words, just like Pandas was able to read CSV, we can actually, and created this data frame, we can actually take that data frame that we've used and write out to a CSV format. So what we're going to say is only USA stations dot to CSV. Remember, only USA stations has this filter. It doesn't have this MUFD ascending false or anything else. So we're going to notice that here shortly. To CSV, and we're going to call our file modified data.csv. And then we're going to say index equals to false. Now, this last part right there is a convenience, but what that's all about is essentially saying we don't want the annoying index in the very front of the file, because when we open it with Excel, we don't want to be looking at that. So when we do that, again, we have the circle, the black circle here, which means we have to do a Command S to save. We get the X, we're good to go. And then we go down here, we have to click on the terminal window here as part of the VS Code IDE. We go up to clear, just to keep a neat working area, and then run the script. Again, the same file is output, but if we say ls, now we see that we have modified data.csv. ls-la, it's readable, so we can actually vi or view modified data.csv, and there we go. So notice that if we do it this way, the sorting is not taking place, because what we're seeing right here is we just wrote only USA stations, which is this variable right here, this data frame right here. So that's why we have, we have the same contents, but we don't have the sorting. Hence you start alphabetical, Austin, Boulder, and so on. Whereas the file that we saw up above was a bit different, was sorted by MUFD. Okay, so that's this part of the program. Now, the interesting thing is to step back a little bit and say, with very few lines of code and using this pandas library, we were able to go ahead and take our manually scraped data, which was saved into a file, and do some logic to it, apply some logic to it, sort by USA, sort by descending, separate only MUFDs greater than a particular parameter. We could even put in here input from the user. What parameter, what frequency do you want to, do you want to have it as a threshold frequency? We can do that, but we won't. The other thing to notice is that this data is constantly changing, which is interesting because this is updated every few minutes. And this, if you look in here, we can look at the file itself. For example, for Austin, the MUFD shown is 29296. If we look over here, Austin shows it 27695. So it's changing with fresh data coming in all the time. So what we'd have to do is do that cutting and pasting and doing this. Well, that's a little bit cumbersome. So is there a way to actually get at the data directly from this URL and download it programmatically? Well, it turns out there is, and that's going to be for the second part of this video. The final part, we're going to go ahead and create a scraper to programmatically access the information from the website. This is the website that we want to do, and this is the data that we want to get to. I contacted the technical contact of this website, and I was able to find out that, sure enough, they have this data in JSON format. JSON is JavaScript object notation, and it's a convenient file to have categories, subcategories of data that can be published on the website, and this one is actually updated in every few minutes, and then use that data for a program. So what we're going to do here is create a new file in our project, and this one's going to be called scraper.py. And once we do that, as again, mandatory, our first line is going to be our shebang, user bin environment Python 3. We're going to import requests library and import JSON library. This is going to be downloading JSON string from URL, which gets automatically updated. For that, what we're going to do is we're going to create an object called response, which is equal to JSON.load string, not loads, but load string, requests dot get, and here what we're going to type in colon, I'm sorry, not colon, but double quotation, https / prop.kc2g.com API stations.json, close the parentheses, and .text. And that URL is the one we have here, where the JSON data exists. So now we print items of interest in the USA. And the only reason for the USA, again, is because of geographical proximity to where I live. We're going to be doing the MUFD, station, and time. For this, we're going to do a for loop for item in response colon, and MUFD is equal to item in the object called, and we do square brackets there, quotation marks MUFD, single quotes. The next one is going to be name, which if we look back here at our JSON file, it's got a subcategory and a category and a subcategory for the name. So we have to do two keys for this particular variable. It's going to be item, brackets, and it's going to be station, and another bracket, quotes, name, and that's going to be that. And then time. Time is not in the subcategory area, but in the category area down here of the frame. So that's where we're going to use. It's going to be item, brackets, and time. Now we need to separate the USA only. So for that, we do if name.find USA is greater or equal than 0. Do the following: print station colon dash quotation name, and do a little bit of formatting here. Formatting is going to need some work, but this gets the exercise or the proof of concept done. And then there, MUFD, and then quote /t/t time colon quotation time. So that should be it. Again, we see the black dot up here, which means we have to do a Command S to save. Now it switches to X. And the other thing we want to do is start a terminal, new terminal. Now we have our little terminal window up here. And then we're in the right place. And we need to change the mod of scraper.py so we can run it. -LA. And now we say scraper.py. And I've got a requests misspelled. So requests. That should be better. We do scraper.py. Oh, we didn't save it. Again, the saving is quite important. Command S. And now we say scraper.py. And there we go. So that is telling us not sorted, but the output directly scraped from the website. So we didn't have to manually cut and paste into a file and then manipulate the data. So with a very few lines in Python, we're able to accomplish that. Of course, we can pretty up the formatting and do the sorting at a future time. But for now, this is shown relatively straightforwardly how this accomplishes something of good use, because now we're able to see that, say, for example, in the Austin and Boulder area, we're in the 30 megahertz MUFD range, which is quite useful. Well, that concludes the video. Hopefully it was useful.